Hi, this is Michael Melman. Now we're going to talk about reproductive physiology. I'll run us through some of the high-yield concepts that are likely to show up on your Step 1. So first we're going to talk about estrogen. So estrogen, it starts with gonadotropin-releasing hormone that's secreted by the hypothalamus, acts on the anterior pituitary. The anterior pituitary will secrete follicle-stimulating hormone and luteinizing hormone. So luteinizing hormone will act on the theca interna cells of the ovary to produce androgens. So androstenedione is a type of androgen. So LH acts on the theca cells to produce androstenedione, type of androgen. Similarly, we have follicle-stimulating hormone. This will act on the granulosa cells, and this will secrete aromatase. So what happens is, this is our granulosa cell. Okay, let's say it's our little cell. And our androstenedione will move into our granulosa cell, and then aromatase is going to act on it. What happens is, it's going to convert it into estrone. So estrone is a weak estrogen, most common in postmenopausal women, but it's a weak estrogen, and that can be converted via 17-beta steroid dehydrogenase enzyme to form estradiol. Estradiol is our most prevalent estrogen in premenopausal women. It's also the most potent estrogen. Testosterone can also be converted to estradiol via aromatase. So for androstenedione, which is a weak androgen, to be converted to estradiol, it first goes through estrone. So androstenedione is aromatized to estrone, and then estrone is converted to estradiol. Or we've got testosterone, which can directly be aromatized into estradiol. This is how estradiol is made in men. Well, as we've talked about, our ovaries, they produce estrone and estradiol, and the placenta produces estriol. Now, estriol is the estrogen you want to associate with pregnancy. So, for all intents and purposes, estriol equals pregnancy. And adipose forms estrone. Once again, estradiol is most prevalent, most potent. USMLE will not ask you this order. This is just for your understanding. But estradiol is more potent than estrone. That's why estrone can be converted to estradiol. And this is the pregnancy one, as we mentioned. Estrone can also be, you can add a sulfate group to it. If you add a sulfate group to it, estrone can actually be made into a storage form of estrogen that can be converted later on to estradiol. And estrogen, it's helpful for the development of the genitalia and breasts, moving from Tanner stage 1 to Tanner stage 5, which we'll talk about the Tanner stages. Assists during the menstrual cycle for ovulation, and it increases the proliferation and excitability of the myometrium and the endometrium. It helps upregulate receptors for estrogen, progesterone, luteinizing hormone, and also has a positive effect on cholesterol levels, which is theorized to be one of the reasons why women tend to live longer than men. Progesterone, and source is the corpus luteum. So following ovulation, the Graafian follicle that had ruptured becomes the corpus luteum. The corpus luteum secretes progesterone. This is what maintains the pregnancy. So it's a complex interplay here. So basically you have your follicle, this ruptures, okay, so your egg begins to move off through your fallopian tube. And now that this Graafian follicle is ruptured, it's now called the corpus luteum, so it becomes the corpus luteum. So this is going to start secreting progesterone. That progesterone that it's secreting is going to act on the endometrium to maintain it, so we can maintain our pregnancy that way. If we didn't have progesterone, we'd have our period. So you say, well, why does a period occur anyway? Like, if we don't have fertilization, we'll have a period, we'll lose the endometrium. Why does that happen if this progesterone is there? Well, that's because if you get fertilization, so you have your uterus, and let's say you get fertilization, you have your placenta will start secreting beta-HCG. Beta-HCG maintains the corpus luteum. So as long as we get fertilization, we get beta-HCG. Beta-HCG maintains the corpus luteum, and the corpus luteum can continue secreting progesterone, and then we can continue to get our maintenance of pregnancy. It's only after about 8 weeks that the placenta itself starts secreting progesterone and takes over for the corpus luteum. Okay, so this is corpus luteum secreting our progesterone initially for the first 8 weeks of pregnancy, and then it's the placenta itself that will take over. So it would be the placenta later in pregnancy, like greater than 8 weeks. The corpus luteum is until 8 weeks. So less than 8 weeks would be the corpus luteum. Adrenal cortex can also secrete progesterone because we have a complex pathway that can start with cholesterol that goes to pregnenolone. Pregnenolone can be converted to progesterone. So we can get progesterone produced in the adrenal cortex, and the testes can also produce progesterone. Now, this stimulates the endometrial glands. Okay, so we'll have continuation of our pregnancy, and it decreases myometrial excitability, whereas estrogen increases it. So we could say that, in other words, progesterone increases the threshold for myometrial contraction, whereas estrogen decreases the threshold for myometrial contraction. So we're going to talk about the Tanner stages of sexual development. So these go 1 through 5, where 1 is prepubescent, and 5 is adult. Now, you can see that the transition from 1 to 5, the USMLE, they want you to know just a few specific details. They want you to know that Turner syndrome, the woman is halted in Tanner stage 1, so there's lack of breast development. They want you to know that Tanner stage 3 is when there's penis elongation in the male, whereas Tanner stage 4 is when there's an increase in penis width and a darkening of scrotal skin. The difference between Tanner stage 4 and 5 in both men and women is that they'll mention hair growth begins on the thighs in Tanner stage 5. If they mention hair growth on the thighs, that's an adult characteristic, and that refers to stage 5, not 4. And another important detail is the difference between the breasts in Tanner stage 4 and 5 in women. Now, in Tanner stage 4, the areolae, which is the hyperpigmented area surrounding the nipple, that actually forms a distinct mound that's elevated off the breast itself. Okay, so the areolae is its own elevated mound off of the rest of the breast itself in Tanner stage 4, whereas in Tanner stage 5, the areolae is not elevated above the breast itself. Okay, so the USMLE really likes that distinction between Tanner stages 4 and 5 in a woman. It shows up occasionally. There's something called virginal breast hypertrophy, where in Tanner stage 4, a 16-year-old girl might feel this massive breast mound behind her nipple, and she worries because she's had a grandmother who's had breast cancer. But the answer is you don't worry, because this can be a normal finding in adolescent girls due to increased estrogens, and it will subside by Tanner stage 5. Now, for the menstrual cycle, we've got 2 stages, the proliferative / follicular and the secretory / luteal. Something you need to know is that the luteal phase, which is from ovulation onward, is always 14 days. Okay, so if they were to tell you that the woman's menstrual cycle is 31 days long, you know that the luteal phase was 14 days, but that the proliferative or follicular phase must have been 17 days. Okay, so it's always the follicular phase which will change in length. So if ever they mention the length of a menstrual cycle, any type of calculation you need to do, remember the luteal phase is always 14 days. So you get that spike of luteinizing hormone, which will induce ovulation. You'll also get a slight spike of follicle-stimulating hormone at ovulation, and it's progesterone. Progesterone is the hormone that is unique to the luteal phase. Sometimes they'll ask it that simply. They'll say which hormone is unique to the secretory or the luteal phase, and the answer is progesterone, which will maintain the endometrial lining. Now, if you don't have an implantation, the drop of progesterone toward the end of the luteal phase will result in a shedding of the endometrium because there's nothing there to maintain the lining, which is why we get the menstruation. There's increased thickening of the endometrium through the proliferative and secretory phases until progesterone begins to decline.
estrogen and progesterone begin to decline. And the USMLE wants you to know that histologically, the glands are quite straight and tubular during the follicular proliferative phase, whereas they become much more coiled or spiral-like during the luteal phase. So sometimes they'll show you histology, and just remember, they're tubular and straight during the follicular phase and more coiled during the secretory phase.